Ma'am, it's getting loaded. 1 minute, ma'am.
Oh, live video ka?
YouTube live.
That YouTube live ka.
Login பண்ணிட்டியா?
லாகின் பண்ணுங்க.
MRO ல. லோ லைவ் போதுல.
எங்க போனது பாதியில என்ட்ரி.
அதுல இது கம்மி பண்ண நேத்து மாதிரி கனெக்ஷன் ஆச்சு அந்த
Ma'am, we shall start, ma'am. There is a problem with YouTube live.
Okay.
I have recorded it. We will post it in YouTube and then we'll share it to.
Okay.
We'll start this. Hari, please proceed.
Let's start now, sir.
Yes, we'll start.
Knowledge is an unending adventure at the edge of uncertainty. A very good morning to all. On behalf of Savitha Engineering College, I welcome you all back to this international webinar series organized by the Department of EEE on Artificial Intelligence and Cyber Security, an advanced approach to power systems. Today's first session will be taken over by Dr. S. Srinath on need for intelligent techniques in power transmission and distribution. The second session will be taken by Dr. Bhaskar Sahu on transmission and generation substations and cyber security in substation automation system. Let us begin this first session with a brief introduction about Dr. S. Srinath. Dr. S. Srinath is presently the professor and head of the Department of EEE in Velamal Engineering College. He completed his master's degree in power electronics and drives from Anna University, Chennai, and obtained his PhD in power quality improvement from National Institute of Technology, Trichy. He has more than 20 years of experience in teaching and research. He has supervised 9 PhDs and 7 MEs. He has published 12 international and 2 national journals. He is a member of faculty interview panel in Velamal Institute of Technology. He has nominated and selected as interview panel member for selection of graduate trainees for Food Corporation of India. He was awarded Certificate of Appreciation from NPTEL, IIT Madras for instrumental role as SPOC. He has delivered special and expert lectures on motors, controllers, power quality, embedded systems, power electronics, transmission lines in various universities across Tamil Nadu. Sir, I kindly request you to take over this session.
Sir, mic.
Is it audible?
Yes,
Yes, sir.
Please.
Okay. So thank you very much, Mr. Hari, and I would like to express my sincere thanks to the management and also the Department of Electrical and Electronics Engineering of Savitha Engineering College for inviting me to deliver the knowledge, to share my knowledge of application of artificial intelligence techniques to to power distribution systems. And as part of the teaching fraternity, it is I think it is my duty to disseminate the knowledge, whatever we have gained through teaching and research. So basically, I am a power electronics engineer, and my research was on to the topic of application of power electronics to power system, especially in the area of distribution systems and more appropriately into the area of power quality. Right. So my work was to design the active power filters for a distribution system, and it was a project done by project sponsored by DST. So I would on the basis of that, few of my research students are doing the research in distribution system, especially for the improvement of power quality. So I would like to share one of such work where we had the application of AI into power distribution system, more into the aspect of power quality. So I think my details are given here. I am there in Velamal Engineering College for the past 21 years. And regarding this lecture, if you have any queries, please post it in the chat box so that immediately I can respond, or also you can send me a mail. Definitely I could able to clear your doubts with the references and whatever knowledge I have. So let us go into the presentation. So you know, basically the distribution system. The distribution system is mainly concerned about the customers, right? So the customers, the aim of the distribution system for the customers is to have a pure sinusoidal wave supply, right? So as part, the power systems are very large, complex, and widely distributed. And as and when the expansion, due to the expansion of loads nowadays, you can see the power system became widely distributed, and also with the introduction of renewable energy systems, lot of events, unexpected events are happening each and every day, right? So why it is going to be widely distributed in the future and also influenced by many unexpected events, and a lot of research work is going on when we integrate distributed generator systems like solar, wind, whatever is not, we whenever we are interconnecting these renewable energy systems, there going to be lot of research avenues. So anyone is interested in research, this can be a best topic for them. And mathematical formulations of real world problems are derived under certain assumptions, and even with these assumptions, the solution of large scale problem is becoming complex and it is not simple, right? So when such problems are occurring, it is very difficult to solve the cumbersome circuit using simulation. But if we have a mathematical model for the same, the solution will become so much simple. And also with this solution, along with optimization technique, a best solution can be obtained. So here you can see a overview of electrical power system, where we have from the generation, transmission to distribution, right? So I think it is self-explanatory. From the generating system via transmission line, and you have substations. Through substation, the customers are supplied. So you have primary customer and secondary customer. Primary customer can be the industry point of view, and secondary customer, household and small scale industries, you can say, right? So where the part of artificial intelligence can be applied, right? So the artificial intelligence techniques can be applied to generating sector, transmission sector, and distribution sector, right? That's what I told. In case of generating station, there are a lot of parameters which can be optimized. Similarly for transmission line and also for distribution. So I will go up, my presentation will be focusing more on AI techniques and also concern to power quality in distribution system, right? So why we need to have optimization, and what is optimization, right? So here lies the answer. The solution of power system problems should be globally optimum, but solution searched by mathematical optimization technique is having a local optima, right? So the optimization, why we need to have optimization? First one, right? Optimization, you know, whenever we talk about optimum, it means best solution. I want a best solution which should have a save in my cost, maximum efficiency. So few parameters which are to be on the higher side, few parameters are on to be the lower side, right? So we should have a optimal solution which is having a best, which is to be a best solution as far as the problem is concerned, right? And also it becomes difficult to deal effectively with many power system problems through strict mathematical formulation alone. See, when I take power system, if I have very strict mathematical formulation, it will be difficult. That's why when we talk about optimal, when we talk about optimal solution, that's why I told you, you can have a range. You can have a range of values from minimum to maximum values, and which suits you best, that can be read as a global optimum value, right? And efficient optimization methods are used in simplifying the formulation and implementation of the problem, right? So what are all the main problems in electric power system? I hope all of us are electrical engineers and we know what may be the problem. Although I listed out problems in the previous slides, so the few main problems in transmission and distribution side are given here, which can be from the generation and transmission point of view. It can be optimal scheduling of generation, right? If you are a student, I'll advise you to please go through the daily newspapers where you can see this optimal scheduling article. At least the article on optimal scheduling will be coming maximum every day or once in a while, once in a week at least, right? What happened to the power sector, which sectors, due to which sector we have maximum power on the previous day or on the previous week, what happened. So that is the optimal scheduling of generation. It should be having an optimum value. And security. Security becomes another important issue where we concentrate more on the control of static and dynamic security. Even a small problem may cause total power failure, and also the security issues. Static and dynamic security issues are important. Then you have power frequency. See, in India, we are following the voltage and frequency level of 50 hertz, right? So if you go to any generating station, you can see the frequency is very important, and always there will be a monitoring of frequency. And especially for students, if you go to any substation, you must have gone to substations, right? There they will take care of this frequency. They will keep on monitoring the frequency always, because further when we come to power electronic loads, when we come to motors, right? Power electronic loads, motors fed with power electronic devices are the motors alone. The saturation point is important, which is decided by the power frequency. Voltage and frequency decides the operation of machines, and hence the frequency control, it should be optimum, and voltage regulation in case of transmission sector. There are a lot of avenues from the control point of view, optimum control point of view, but we have listed out a few from transmission line. Whereas if you take the distribution line, you can see the load dispatch center, it takes care completely the load. Whatever load we have, it takes care of the load dispatch center, takes care of it. In Chennai, we have it in Mount Road. And I told you from distribution sector, the substations and reactive power optimization, right? So in my case, in this presentation, we have taken the distribution side where we have analyzed the improvement of power quality for a distribution system from the distribution system point of view, right? Next, I told you already, when we talk about optimization, so optimization here, a mathematical model, it can be designed as a mathematical model whose objective is to minimize undesirable values, right? I told you few functions we can minimize, few functions we can maximize, right? So we can concentrate the minimizing values for cost, energy loss, errors. If you consider these are to be minimized, or maximize the desirable values, for example, efficiency, quality, and profit, right? Subject to equality and inequality constraints. I told you already, constraint. Always you should have a constraint, because we cannot get any ideal solution through mathematical model. There should be lot of constraints, right? We can arrive at an optimum value satisfying these constraints only, right? So here, for example, I have given, you can have your objective function either to minimize or maximize if x is the variable function of x. We can have equality constraints and inequality constraints, which I have given you here, subjected to. Next, the inequality constraints can be given in different ways. It can be made to lie within inner range as well as outer range, upper range or lower range, or it can be less than 0, greater than 0. It can be any constraint. So that's why I told you the types of optimization problems based on the constraints can be, it can be a constrained optimization problem or unconstrained optimization problem. We can have both cases. So here, all power system components are defined by a set of quantities. It can be a fixed quantity or variable quantity, and they are called pre-assigned parameters, right? And other quantities are treated as variables which can be called as decision variables, right? So we can have fixed variable, we can have a fixed value as well as decision variables for a optimization problem. So for a unconstrained optimization problem, we can have function of x is equal to exponential x1, x2 up to xn, where which minimizes or maximizes the value of function of x. What are the design constraints, right? So design constraints are, they cannot be chosen arbitrarily they have to satisfy certain functional and other requirements, right? These restrictions must be satisfied to produce an acceptable design and collectively called as design constraints, right? So if you take any problem, see, when we talk about optimization, you have constraints into mind. These constraints can be either functional constraints or geometric constraints, right? If it is a functional constraint, it should have a characteristic limitation, or which we can call it as behavior limitation. And if you have geometric constraints, it is a physical limitation, right? Hope you can understand from the words. All these constraints we have to take into effect when we talk about your optimization problem, right? It can be either functional or it can be geometrical, right? Most probably in case of a electrical circuit, for example, the functional constraints can be the value of voltage, the value of current, how the circuit behavior changes. See, I can have an optimum value at any value, but it should have a limitation. It should have a minimum value and maximum value, for example, voltage, for example, current, which decides the behavior of the circuit, right? Physical limitation, what I mean to say, you can arrive at any value. Again, there is a limitation for the size of inductor. There is a limitation for the size of capacitor, which can be practically possible to be made to be fit in the circuit, right? Hope you can get what is this physical and behavior limitations available with optimization in case of design. So next is just for example, classification of optimization problem. Based on the nature of equations involved, we have linear programming problem and non-linear programming problem, mixed programming problem, and dynamic programming. See, there are a lot of experts who are all giving lectures on artificial intelligence here. I don't want to go into the depth of this, right? So with respect to electrical problem, we have sorted out the issue of power quality. So the linear programming problem, it can be either in simplex method or interior point method, and non-linear can be geometric programming and quadratic programming, and integer programming as well as dynamic programming. This is the classification how your optimization problem can be dealt with. So artificial intelligence, right? Till now we have seen optimization. What is optimization? How this optimization can be applied to any problem? What are all the constraints, right? Next comes to the topic of artificial intelligence, right? First of all, we should know what is artificial intelligence, right? Nowadays, wherever we go, wherever you are there, in whatever field you have, whether you are in electrical, whether you are in mechanical, whether you are in civil engineering, people start talking about artificial intelligence, right? What is this artificial intelligence? So here, just you can, I have shown you a picture, right? So it is a brain, right? It is a brain-like structure, which is connected to a lot of applications worldwide, you can see, right? So nowadays, wherever you go in the era of digital technology nowadays, see everyone nowadays, without finding, sorry, without a mobile with a person, we cannot find any person without a mobile. Everybody is having a mobile. Everybody wants the work to be smartly done, right? Smart work, you know what is smart work? All work we want in fingertips. We want mobile banking. We want banking to be within us. We want the purchase, online purchase. We want online purchase with us. We want to finish all work sitting at a place, right? The best example for artificial intelligence and virtual machine, I can tell you. See, you must have seen in the whenever you visit a website, especially for example, you can test with this. If you go to any insurance sector or any website, there you must have seen one chat box, right? If you start chatting, immediately one message will come. So and so is waiting for you to chat with you. Are you ready? You clarify your doubts, right? Do you think a person is sitting over there to answer your query? It is not at all. Everything is done by artificial intelligence, right? You have been given an avenue to talk you have been given an avenue to realize you are talking to a person. No, it is a machine, right? So similarly, this artificial intelligence, wherever you can find the application here, right? So you can see lot of applications I have shown here. Everywhere, this is purchase, this is house, this is power transmission, car charging. If you see nowadays, again electric car, wherever you go now, artificial intelligence takes the place. Without artificial intelligence, in very soon it will become a general practice to use artificial intelligence with us. In every field you can find the application of artificial intelligence, right? So here, despite the success of algorithmic approaches in the optimization problems, there remains a large class of problems that elude complete solution in a conventional setting, right? That's what I explained. I told you the problems require use of knowledge base. If you have a knowledge of working, what to do, how to do, when to do, that's all. So use of knowledge base to mimic human thinking. Our human thinking is only this, right? So if you are able to mimic the human thinking, definitely you can use artificial intelligence and operators decision, particularly in practical solutions. So you want to make a decision. See, human thinking involves why, when, what, for, and also the decision whether I should do it or I should not do it, right? And also how you can take this decision over a experience gained over a period of time, right? Simple example I told you already. If you consider any question, if you consider any website, I told you already, people talking to you, they are simply artificial intelligence. Through artificial intelligence, it is made to, you are made to think like a person is sitting there and answering your queries, right? So it does nothing. It collects the information from you. It collects the information and it tells you what to do for a particular case. That how they are doing, it is the experience gained over a period of time and characterization by network uncertainty, load variation, right? So depending on the situation, the artificial intelligence takes decisions. Next, few artificial intelligence techniques which usually we use are artificial neural networks, fuzzy, genetic algorithms, PSO, particle swarm optimization, colony optimization. It can be ant colony, bee colony. There are a lot of algorithms which finds its own merits and demerits, right? Evolutionary computation, hybrid artificial intelligence technique, and lot of techniques are available nowadays to solve power system problems, right? You can ask me, what is the beauty of this? Why we want to go for this artificial intelligence techniques, right? See, there are a lot of creations by God in the universe which has its own characteristics in nature, right? Whatever we think, we can't expect the same thing to be taught by the other creatures. That's why you can see nowadays in the literature, or in the research, in the literature of research, you can see lot of techniques are coming one by one, one by one, one by one every day, which we are by research we are able to get good results by mimicking the same behavior into our system. Whatever we mimic, the system will behave like that. For example, ant colony optimization. See, ants are having certain behavioral items which can be made for a circuit to work in a similar fashion. When I work in the similar fashion, ants are having a best capability of storing the things. It can remember the path where it goes. Similarly, bee colony. Bees are living in a colony. It has a specific characteristics. And if you browse net, you can get all these algorithms, and sometimes you can find the codings are also available. Right. So I want my circuit to take up these qualities to work and to get with a best optimal solution for this. Right. So I told you now applications for planning. See, the characteristics for best example, I can tell you. Actually, we have used another algorithm to tell you about the basic which ant colony optimization. We can have planning. It plans how to store the food, where to store the food for the period which the ants cannot come outside, right? So planning, operation, analysis, and control everywhere in the system. If I take all these items are available with our electrical engineering, we need to have planning in terms of long-term forecasting, load forecasting, capacitor placement, voltage control, where we require planning phase. Similarly, when we come into operation, we need optimal solutions for economic dispatch, how the loads are to be dispatched, unit commitment, right? Which unit has to be started on or which unit has to be made off, depending on the load demand, short-term load forecasting. This time the load is going to be more. So from operation point of view, I want to find out the optimum solution, fault diagnosis, load flow, static and dynamic security assessment, hydro scheduling, transient stability, etc. Those who are planning to do their projects are further continuing doing your research, you can have all these things into mind when you proceed to find out a topic for your research. Next is analysis. We need the system to be stabilized always. So what we can do. And next, control point of view. So we can apply optimization and AI techniques wherever we want, and there are a lot of avenues in electrical engineering for the same. So next, coming to the work, application of AI in power distribution system. So here, actually one of our research scholars, and we have done a work to find out a optimal controller for power quality improvement in power distribution system using an enhanced grasshopper artificial neural network technique, right? So I think all of you know the grasshopper, and recent days along with COVID-19, you can see there is a lot of threat due to this grasshopper also, right? See, please browse this grasshopper. They have a specific characteristics in finding their food. So we have used the specific characteristics, that is when the grasshoppers are in the very young stage, they are not able to move, they are not able to fly, they are moving in a particular fashion along with their colony, along with their colony. Recently, also in newspapers, you must have seen the picture of this grasshoppers when they were sitting in a tree branch. It was completely covering. See, you can't see a grasshopper as an individual member. It always functions in a group, right? There is a specific characteristics, and they are characterized by three forces. They are characterized by three forces. One is the mutual force, other is the gravitational force. Right? There are three forces which makes their characteristics and their lifestyle similar. And you can see a comfort zone. They always maintain a distance for this force. They always maintain a distance. That's why you can see a comfort zone. They always try to live in a comfort zone. So if they go out of the comfort zone, immediately they want to try to come into the comfort zone. This was the characteristics which was taken, and this was made, this was mimicked in our circuit, and we were able to get a best result out of this technique. So it mimics the behavior of grasshopper swarms and their social interaction, right? And the execution of this optimization takes more number of iterations. When we use this grasshopper optimization, it took more number of iterations, and hence we have introduced crossover and mutation to achieve enhanced grasshopper optimization for to find out an optimal solution in this case. So how it is being done, right? Actually, this is a published work. I'll give you the reference. You can find out. You can please browse the net and you can find out the paper, and please go through it if you have any doubt. So it is a combined execution of both grasshopper as well as neural network, right? Already you know neural network. So neural network, they mimic or the behavior of brain is completely made outside. So it is enhanced grasshopper is one of the meta heuristic algorithms which mathematically models and sorry. Yes. It is the meta heuristic algorithms which mathematically models and mimics the behavior of grasshopper swarming in nature and solving optimization problems. It is relatively a crude electronic model based on the neural network of the brain, and the output of grasshopper optimization is given as the input to ANN controller for producing the optimal pulse, right? So let us come to the actual system where we want to improve the power quality using this optimization technique. I hope this structure, you must have seen this structure. So here I have taken a distribution system which is feeding, which is giving a power supply of 234 phase voltage 230, and you can see it is feeding nonlinear loads. So you know nonlinear loads always they inject harmonics into the system, and the source current is completely getting disturbed. So when the source current of a distribution system is disturbed, it on the back, on the progress, it affects the entire system which is connected to it, making the quality of power very poor, right? So in order to improve the power quality, we can connect a active power filter into it, right? So mostly the current quality problems are taken care by shunt active filter. And here, in addition, we have connected a passive filter also for selective harmonic elimination. Like here, we have connected it for 5th and 7th harmonic elimination. I think you know the advantages. There are a lot of advantages when connecting a shunt active power filter. It acts as an active source. So whenever there is harmonics into the system, see this diagram might be clear. This diagram might be clear. So in the AC source side, you have the source current and the load current started to have harmonics when I connect a power electronic load there, right? So it injects the nonlinear load injects harmonics into the system, and the shunt active power filter starts filtering out. Actually, the shunt active power filter is basically an inverter connected to a separate DC source which is connected in parallel to the system, right? And in order to eliminate the selective harmonics, we have connected shunt passive also into the system, right? So here the difficulty comes. Here the difficulty comes when we need to decide, when we need to stabilize the DC voltage, right? Actually, this DC voltage which is connected to the inverter is usually charged, will be charged by the same current of the system. So the shunt active power filter, it's working as a converter as well as inverter. When it should act as a converter and inverter, the pulse are very important. Whatever pulse we are giving to the shunt active power filter, on one side it should charge the capacitor, it should make the capacitor to have a constant voltage across it, and also it should start compensating, it should inject negative harmonics into the system so that your source current is always a pure sinusoidal. That is the objective of this active power filter. So I told you here the functions, here the objective function is to have a best quality pulse. My pulse should be best enough so that it at times it should be used to store the capacitor, charge the capacitor value and balance the capacitor, and also it should inject negative harmonics, right? Hope this figure is clear. So here you can see the actual system under simulation is shown here, where the source is supplying a nonlinear load. Source is supplying a nonlinear load where you can see a shunt active power filter is connected to the system, and you can see this DC voltage is maintained by a separate controller. This here comes the optimization problem. Here comes the optimization problem. Now these pulses you can see, there are pulses which are all going from here, right? You can see 6 pulses. So your PWM controller here, which is having a backup from your optimal solution algorithm, it gives the pulses accordingly to the switches. So when I have a optimal controller here, this optimal controller takes care of the DC voltage as well as it takes care of the pulse which I am giving it to a shunt active filter, right? So here the parameters under monitoring are from source side, you have source current, and what are all the voltages which you are supplying to the system. You can see this is source current. So source current gives you the information to the controller algorithm here. It gives input to the controller, which further decides what is the voltage, what is, because you can see this when this is having a harmonic, this is having harmonics. When this is a harmonic current, the same harmonic will get reflected in the source current, right? So the when I measure the source current, I can find out what is the negative harmonic to be injected from here. When I inject negative harmonics into the system, so from here, the harmonic currents, positive harmonic currents, negative harmonic currents, finally, this current flowing into the source will be completely harmonic free. This we were able to achieve a better result when we applied this EGOANN technique. So this is the publication details. You can just browse this, and this is online copy is also available. So here, this algorithm optimizes the data set of fundamental and harmonic loop parameters such as terminal voltage and DC voltage for the shunt active filter based on load changes and parameter variations of the system. And with the accomplished data set, ANN accurately predicts the parameters and produce optimized control signals. And this technique guarantees the system with reduced complexity for the harmonic mitigation for the power quality event, and hence accuracy of the system is improved, which is a proven result. So I think this is the description of shunt hybrid active power filters given. It is used with a PA-based controller, and the gain parameters are optimized with the help of enhanced grasshopper and ANN technique. And this strategy is used for generating the optimal pulse for the inverter of the active filter. So here the flow chart is given for your reference. So here initially the particle swarm, initially the population is created, then fitness of the population we are checking, then here ANN update the position using crossover and mutation. So by this we are checking the maximum iteration before achieving the optimal result. So how the optimal data set is obtained? By the training phase, by the ANN phase. So here initially the inputs PI gain parameters such as GP and GA are randomly generated in the initial process, and then random generation based on the initialization, random behaviors of gain parameters. So randomly based on the initialization step, random values of KP, KI, GP, GI are generated. Next, this is evaluated inside the fitness function. So the position of the grasshoppers is evaluated using the fitness of population, whether it is fitting into the function. Next is updating the position. See, I told you for grasshopper, the position, it will always try to fit into the comfort zone, right? So it is always checking, we are updating the position. So after the fitness calculation of each individual, the best optimal solution is updated according to the value of J, right? We are trying to find out the nearest value of PA parameters. So this PA parameter you might have done in trial and error method. Now we are using this grasshopper technique for finding out the best solution. So here then crossover is achieved when two individuals, and in between the mutation process, the individuals are mutated randomly based on the given fitness function. So here the functions are given. If you refer the paper, you will get complete details. Next, when a proper value is reached, when the iteration reaches the maximum value, you have to stop. You have to terminate the function, and you can get the optimal values. And so once you get the optimal value, this is fed as an input to the ANN control, and this ANN is trained based on both input and output variables. During the training process, hidden layer obtains the weight of specific time delay, and also the weight adjustment of ANN is done by back propagation. Hope you must have known the back propagation, which takes care of the predecessor outputs. So based on the previous outputs, the output of the present stage is decided. So we have used back propagation algorithm in this. So we have taken different case studies. Different case studies are taken with balanced supply voltage as well as with unbalanced supply voltage. So first case we have taken balanced supply voltage and a three-phase rectifier with DC motor load, balanced supply voltage with three-phase unbalanced RL load, balanced supply voltage with three-phase rectifier with motor load and a three-phase both combined, case 1 and case 2 combined. And fourth case with three-phase rectifier, DC motor and unbalanced RL load together. And last case along with four loads, right? And sixth case we have taken unbalanced supply voltage with three-phase rectifier with DC motor load. So here you can see all these cases, what and all has been dealt with. And hope this shows you the effectiveness of the scheme, effectiveness of the enhanced grasshopper scheme, where you can see the source current, source voltage, shunt active power filter current, load current, and load voltage. Although you can see here, it is a DC motor load with fed by a three-phase rectifier. Although the load current is completely distorted, you can see the source current value here. You can see the source current value and also the shunt active power filter, how it injects the negative harmonics into it. Next case, balanced supply voltage with three-phase unbalanced RL load. So this is the load current. This is the load current, and here you can see the source current. Here you can see the source current. You can see how the harmonics, negative harmonics are injected using the shunt active filter. And next case, we have taken three-phase rectifier with DC motor load and also a three-phase unbalanced RL load. So here you can see the variation. You can see the variation of load current, and you can see we are getting almost perfect sinusoidal current, perfect sinusoidal shape of current in the source. And this is with three-phase rectifier DC motor load and three-phase unbalanced RL load. You can see completely the source current is becoming sinusoidal and harmonic free. And this is balanced supply voltage with three-phase rectifier and DC motor load, and we have taken all the possible cases, right? So the source current, mainly for power quality improvement, we have to see the source current value. And final case, when I have unbalanced supply voltage, the second graph you can see this unbalanced supply voltage with three-phase rectifier and DC motor load, and it shows the current. You can see, since the source is unbalanced, you will have an unbalanced source current, but you can see completely the harmonics are neglected. The harmonics are eliminated here, right? So when we compare the value of THT, the THT is compared with simulation of the basic model with PI tail and error and grasshopper and enhanced grasshopper with ANN. In all cases, you can see with this optimization approach along with ANN, the results obtained are better compared to the other optimization method, right? I will never say this optimization method is giving me the ideal result, right? Each and every optimization method has its own merits and demerits. It is up to us to use which method depending on which constraint. Somebody has raised their hand. Joel?
Yes, sir.
Yes, sir.
Somebody has raised their hand. So can you please unmute them?
Yeah, I'll unmute, sir.
No, sir. It's lowered.
Some Ravi
Anybody
Kiran,
have?
somebody came.
Ravi Kiran, sir, you have any doubts? You can post it.
There are options previously that if you want to go for PI and if you want to, you don't
Hello?
want to go for the derivative term, you just select this PI controller. So it will only give you the PD controller, PI controller, and
No, not able to get you, please.
no more the PID controller. You will see.
Am I audible, sir?
Yes, sir, please.
Sir, when you are comparing this, what we could like for most of the cases, we could able to get very small improvement, right?
Yes,
So
of
in
course.
that case, how do we think that how do when some suppose if we take the same work to any journal
Yes.
and when they ask about what is the improvement or what is the novelty in this technique or something like that, how do we defend it?
No, so that's what I was telling. See, you can combine any optimization technique, provided you have to test your network with the other techniques. It should be a proven result. That's all. You can combine any technique. Like here, we have combined the grasshopper with artificial neural network. You can combine it with any fuzzy network. You can take another PID controller, right? You have to test your system with all these parameters, and you should see to that your network, what is the value compared for the same system. For the same system, what is your value? Definitely
Yes,
you
sir.
can definitely you can defend on it, provided you are testing your system with all the other approaches under your comparison. Definitely you can do it.
Yeah, let us assume I have done all the test conditions are same, and if I am comparing two heuristic methods,
Yes,
and I ensure that even population and all these whatever parameters we talk about,
yes,
I ensure that they remain same,
yes. See,
almost same, or a little bit deviation may be there, but still we got only 5 to 10%, not even 5 to 10%, I think, somewhere near to that. So
yes.
how do we, if they are asking about what is the point in doing like that, how do we defend? Do we have to
No,
go
no,
for
no.
like set space will be the same, right?
See, definitely when you implement this practically, it has a large deviation. We have done real practical work on it. We have done practical work on it. When you implement a small
Okay.
change in the PI value, depending on your algorithm, result of your algorithm, you will get the harmonics values with a large difference. Although the values of C here, we have shown the source current and load current percentage values. When we implement the actual PI values there, where actual PI values, it creates a lot of difference in the simulation. You
Hmm.
can see like this 0.18, 0.12. But when you, for example, I'm saying you, but when you do it practically, you can visually see the difference. You can visually see the difference when you do it in a practical case.
Okay.
So if you implement this practically, then you will come to know. It is only simulation result which is taken, and I have done the practical case also. It is also being done.
So practical means, are you tuning that in the real time? Like if there are any parameter changes,
Hello.
again, will the program run for? Am I audible, sir?
Yes, sir. Yes, sir. Please.
Practical in the sense, I just want to know, is it online tuning something like that, sir, or we have to even for practical? If there is a real-time system, we tune it before and then apply it.
No, you have, if it's a practical system, you can implement this online using any processor. Using any processor, we have used DSP processor. By using the processor, you can tune with different values. You can find out the optimum. When you apply this optimum value, you can see the real-time difference in the harmonics created by the system.
So in those cases, we can defend based on the convergence, right?
Yes,
Converging
exactly,
time,
exactly, 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 exactly.
not just based on the result. At the same time, we have to
You can
talk
take
about even the convergence rate.
you can take the converging time and also the DC voltage rising time. There will be a definitely change in the DC voltage rising rate. How the DC voltage rises from zero value and it starts maintaining at a particular value.
Okay.
When you
But
use
when we talk about optimal sizing, all these things, I don't think then this advantage will be lost, right?
no, we have not checked in that case. Definitely, it will have an effect on the optimal sizing also. Sizing of capacity, we have not done in that route. That's all. We can do it.
Sure, sir. Thank you.
Welcome. Anybody? Okay. So let me continue. So here we have done compared the THD values, and here you can see. So it took 23 iterations, as you rightly pointed out. It took around 23 iterations to reach the final case. So you can see the values of GPI, the gain values of PI. It is given here, and convergence. As you what rightly pointed out, the convergence characteristics you can see here. Actually, there was a good improvement in the DC voltage settling time also. The rise time of DC settling voltage was less compared to the other methods when we had the real case. So the THD comparison, it is done, the maximum and minimum values. So the statistical comparison of results was done, and minimum, maximum and average THD obtained by this algorithm over 50 trials are compared with those of existing approaches. And it was the maximum value of 0.99 and 0.73. It was a proven result and it was accepted also. This is the reference. You can have a note of this. And I would like to answer if you have any further queries.
Participants, any queries can raise your hand.
Sir, we have certain queries posted in the chat box. I will read one by one, please.
Please.
The first question: how can we develop an algorithm for fault location in distribution networks? What is the best tool or technique to work on? This is
Can you repeat it again?
Yeah, sir. How can we develop an algorithm for fault location in distribution network? What is the best tool and techniques to work on?
See, there are a lot of techniques applied for this. You can use fuzzy logic, neural network to find out the fault location. First, you need to find out the magnitude of fault current and the fault impedance. If you are able to find out the fault impedance and fault current magnitude, any technique you can apply. If you are starting with, you can use artificial neural network, otherwise a fuzzy logic for solving this fault condition problem.
Okay, sir. Thank you. The second question is how to write minimization function and objective function constraint for the power system fax device.
How to write
Minimization function and objective function
for a fax device? See, for a fax device, the minimizing parameters mainly it should concentrate on reactive power compensation. Mainly, it should compensate on reactive power compensation, and as I told you, the maximum can for minimizing it should be on DC voltage also. DC voltage, size of the capacitor, all these points are to be minimal function in case of a fax device. In case of maximization, in case of maximum quantity, you can have any parameter like the range up to which your active filter, your fax device can support. The range up to which your active filter can support, that can be a maximized function.
Okay, there is one interesting question. That's the final question too. Why is the source current and load current different if only one source and one load was used in the simulation?
See, for the picture, whatever I have taken here, it is looking, the scales are different. But actually, when we tested, it was not different. It is same only. For the figure, whatever presentation we have shown, it looks like same since the scales are different. You must have seen The load current and source current, it is not different. Almost it is same. It is not different. We check the case.
Thank you, sir. Thank you, sir. One more question, the last question too. If we use an optimization algorithm to an existing problem, what novelty can we claim if there is a very little improvement in it?
See, that's what I was answering, Mr. Ravikiran.
Yes,
You
Ravi.
can,
Yes, question. Sorry.
yeah,
That question answered,
you
sir.
can combine any technique, no problem. You can combine any technique. You should prove your convergence rate is, your convergence is good. Within the minimum number of iterations, you are able to provide good result when you compare with the other optimization techniques. That's all.
Okay, sir. Thank you so much, sir. The questions are over. Hari.
Hari?
Yes, ma'am.
So
Yeah.
if anybody is having any doubts further, you can definitely mail this to me. No problem. I'll be happy to answer this.
Sure, sure, sure.
Sure, sure, sure. Hari, continue, ma.
Akshay will continue, ma'am.
Yeah, yeah. Ask him to continue.
One second. He's not made.
Yeah, unmute பண்ண முடியல என்னால.
Yeah, now it is done. You can start now. Akshay Ganesh.
Hi, sir. Hello. Do you hear me,
Yeah.
sir?
Yes,
Yeah,
it
yeah,
is
yeah.
audible.
Thank you, sir. It was a wonderful speech. Now let's move on to the second session of today's webinar. That is from Bhaskar Shahu, sir. After completing his master's in engineering from BIT Pilani, Bhaskar Shahu joined GEC Alstoms in 1996 at their Palavam work, Chennai. After his induction, he was in tendering, moved from there to other department, that is sales support, application support, IED sales, relay commissioning. In 2012, he moved to Schneider Electric, Saudi Arabia, handling sales support for substation automation business. In 2016, he moved to Schneider Electric India as head of technical IED in Energy Automation Center, managing the L3 application support team, protection commissioning team, and relay repair center. Sir, now you can start the session, sir.
One second. I thank Srinath sir for the wonderful session, and he patiently answered for all the questions. Thank you so much, sir. We'll reply you. There are many more questions posted to you in chat, and many more participants are asking you your mail ID. We'll share it to them. They'll ask the questions in private chat, sir. Thank you so much for the wonderful session. Thank you, sir.
Thank you.
Yeah.
Sir, I welcome Bhaskar
Once
Sahu,
again,
sir.
thank you, Srinath, sir. Yeah.
I welcome Bhaskar Sahu, sir.
With his, yeah.
Okay, ma'am.
Thank you.
Yeah.
Oh, good morning.
I will. Yeah.
Am I audible?
Yeah, sir.
Am I audible? That's what I just want to check.
Yes, sir. Yes, sir. You are audible, sir.
Okay, let me just share my screen and then
Yeah.
do this. Just 1 minute. Is my screen visible?
No, sir.
Just 1 minute.
Yeah, it is visible now, sir.
Okay, perfect. Just open the search. Okay. So it's good to start.
Yes, sir.
Okay, perfect. Now let me just try to squeeze, because I had a very tough time because the subject is so wide. So I had a tough time compiling what to talk in this short session. But nevertheless, I have tried to squeeze in, which is very important, and from the concept point of view, and from the basically what is really applied in a substation now. Because normally we are more tuned to giving sales and marketing, and then talking more technically, which is there. But it's a bit out of off track when we are talking only on the concepts. So here I'll be just focusing only on the concepts which is there. So there are certain things which is there which may be generic in nature. If it is generic in nature, then just do let me know, and then I can just start rolling it, which is there. So this is the agenda which we will be covering today. I will first touch on the definitions which is normally used in the cybersecurity. Then I'll just give an introduction on the cybersecurity which is there. Then we will zoom into some the standards which are currently talked about, and there are a lot of standards which also we will just look into it, and we will just zoom into two of them very briefly. One is the NERC-CIP, and then what we called as the next standard, which is pretty important, is IC 62351, which is applicable purely for a substation environment. So because there are so many wider scopes for the control centers, there are a lot of standards. So we are not going into all the standards which are there. We'll just see on this. And then what we do is some 5 basic steps for a secured substation, what is adopted, which is there. So we will talk about the physical and electronic access. Then we will talk about the hardening, then role-based access control and user authentication, then secured logging and monitoring, and then secured communication. Then last, we'll conclude this session. And if any queries are there, just do put it in chat. Later on, we can just come back and we can go into it. Is that okay?
Yes, sir.
Okay, perfect. Now, first thing is, it is very important that we know the terminologies which is being used in cybersecurity. I have just listed out some terminologies when we see this in any public domain, particularly electrical substation. When we, the first thing is what people say is asset. Asset is basically is what we want to protect. So in a substation, it will be your computers, your bay computers, your relays, protection devices, your operating workstation. So these are basically what is called as an asset. There are other assets like your transformers, your breakers, the isolators, the towers. There are other assets, but assets will define what we want to protect. The next terminology, what we call is a threat. Threat is what we call is a potential danger. What is then the next terminology? What we should know is vulnerability. Vulnerability is a weakness that may allow an unauthorized access or exploit. So what is an exploit? Exploit is like a software or other codes that take advantage of the vulnerability. Exposure, instances when the vulnerability is exploited. Safeguard or countermeasures. This is basically your mitigation methods for protecting the potential risk. So basically what you do is you have an asset, you identify a threat, then you say that this is vulnerable. That means it is there is a potential to be exploited. And then what you do is you put a safeguard or countermeasures or what we call as a mitigation methods to counter this potential, this threat. Then what we say is the risk. So if I don't do these countermeasures, what is the risk? Okay, then my computers will be down, my link to the load dispatch center will be closed, my this thing. So this is what we call as a risk. So these are some definitions which is important as we move forward. The next thing which is called is what we have is threats. Now, when we say threats is what we say is we classify threats as unintentional and some what we call as intentional. Unintentional is like a natural disaster. What we say is like a floods or earthquake and all those things which is there. Then there are also errors which is unintentional, like it's a human error. Instead of closing the circuit breaker of X for X feeder, he has done for Y. So this is also a human error. There can be error in the software or in the hardware of the devices which is there. Then intentional, which is there, and intentional list is, it's very long, where it is the internal or external source, and internal attackers, which is there, or dishonest or disgruntled employees, because these are also there, because there are some cases reported in Europe where, employee was very annoyed with his boss, so he wanted to teach his boss a lesson, and this is the fact. So what he did, he made a small program, and when his boss is manning the station in some hours of the day. So he made a program and he made the substation to go on a blackout mode. So what happened is boss was punished. So this is what we call as a disgruntled employee. So this is also a type of a internal attack which is there. Then dishonest visitors, like means visitors who are have got no interest. Let's say going to a power grid station and I just log into the computer and I just put some this thing. So these are, then there are other motivation like games, monies, terrorism, which is there, which I will just browse through it. Now, what are the threats? These are some sample threats what we see, which is there indiscretion by the personnel. That means it's a very typical example. Employees sticking their password on the computer. So it is very common. We have seen that yes, it is a common this thing. So we put up, this is the desk and the operator desk. This is the password. So what they do is on the board they will stick a, this is my password. Then to ease the operation, what they do, they turn off the security measures. Employee so that we don't have to change the default password. So what happens is there are systems which will invoke change of password every once in 2 months or once in 3 months. So what happens is a lot of maintenance person say, oh, they get fed up. This is why, what is this? Let us re-invoke this. Let us turn off this measure. So these are called bypass controls. Authorization violations. Now here what happens is you have checked, approved, and the way what we have, we also have the similar system in place in electrical substation. So what people do for making things easier, so the guy who checks it, he approves it. So you have, this is called what we call as authorization violations. Man in the middle. Man in the middle is basically the gateway from the information which is going to the load dispatch center, which is there. So it is tampered with, you tampered with the data unnecessary and give a incorrect information which is going from the substation to the local load dispatch center. Then what we have is resource exhaustion. So you have the computers which is there, and this equipment is overloaded, which is there. It has got some, let's say, virus or something which is there, or some certification which is there. It has expired. Let's say the McAfee or something has been uninstalled, or the Windows which is there is not upgraded with the right patch. So these are all things which is. Now we come to, so this is the first part, which is what we talked about, some definitions. What is a threat, and what are some likely types of threats, and what are the typical examples of some threats what we have seen in electrical substations. Now we come to the just an introduction of the cyber security on specifically on a substation. So this is a survey which was done in Europe almost 7-8 years back, and the survey, when the people started implementing cyber security, the survey was done is if you implement as a user, the utility was asked, if you implement cyber security, what is going to benefit you? So there are 5 options which was given. One, it says none. Second, it says I will increase my quality of service and efficiency. Third, it says I will comply with the regulations. Then fourth is new business opportunities and differentiate against competitors. So if you see here, the 2 and 3 is almost populating about 85 to 90%, which says that if by implementing cyber security, the users feel the quality of service and efficiency will improve, and it will also comply to the regulations or the government laws which is prevailing in that particular region or the country, whatever it is. Okay, now we just done what does cyber security mean. So when we say it is availability of, improve the availability of grid by protecting the system against hacking. So hacking is the most common thing what we have seen in today's world. We have seen utilities, computers getting down, load being shared, the whole country going on a blackout. So there are a lot of instances which we have seen on this thing, which is like protecting against systems against error. So that means the system which is there, it can also generate an error if we are not updating. So if I keep a Microsoft Office which is there and I don't update my patches which is coming from the Microsoft periodically, which means that I am running a system which is vulnerable. So that means that is the reason why it is Microsoft is recommending that yes, you should update the patches as and when it comes, which is there. So just to prevent these errors popping up. So this protecting errors, improve operational maintenance process, improves organization of the power utility. Now, the most important thing what we we should understand like it is a continuous process, and it is not only the technical thing which is playing a key role in the cyber security. As we move forward in our discussions, we will see it is also equally important for the organization which is implementing cyber security also to be equally has an important role. And it is a continuous process. It is not that today you say that today you are cyber secure. It doesn't mean that, and if you don't update yourself, so it doesn't mean that tomorrow there is a chance that you might get hacked. So it is always a continuous process, because always new vulnerabilities are getting discovered, the grids are changing, and so on. Okay, this is the slide which I just wanted to update, which is giving a synopsis of the full standards view. Now I'll just explain from the left. There are some standards which are organizational dependent, and there are some standards which are purely technical. Now on the y-axis, which is there, we have the the domain. Like say smart grid. For smart grid, we have NIST 7628, which is there, which is partially organization, partially technical. OIV French, this is Liver Blanc, is a French utility standards which is there, and it is purely organization driven. Then there are something which is there is a utilities. Utilities are like what we will discuss, which is called the NERC-CIP, which is a North American regulatory body. Then we have a standards from a utility to manufacturer. That means in Germany, VDW is a group of the company which is there, or the utility company, which is imposing to the manufacturer the standards. So this is what we have VDW. So that means if you want to sell any systems, or if you want to any system which has to be installed in VDW, must comply to this standard. So this is one. Then if you take in the industry automation, so which is prevalent industry in oil and gas, which is there. So we have IC 62443 as one of the standards which is there. Then if I come, and all these standards, if you are seeing that these are all basically on particular segment, either focusing on the organization or partially technical. But the standard which is purely 100% technical, irrespective of the segment which is there, is we have IC 62351. So that is where the reason I have just shown it in a like a Y block, cutting across all the segments, which is the smart grid, utilities, industrial automation, oil and gas, which is there. We have also the IEEE 1686, which is there. That is also one standard which is there. Then we also have IEEE C 37240, which is there. So this is mostly on the utility side. So the green ones are what is there is what you see is purely technical driven. And this is M940 is the European mandate, which is big, slowly popping up, which is there. So this is, if you come to see the spectrum, it is a very wide spectrum. The standards which are being defined only in the substation levels. I'm not going into the control center level. So this is purely on the substation environment, what is standards which is being defined. Okay, now this is the most important slide which is there, and I'll just spend some time here on this to convey the message to you. If you take the cyber security in a substation, you know, it is we can classify into three broad pillars. The first pillar is there should be a organizational, or the user who is implementing it, he has an equal role to play. So that is what I called as an organizational. The second pillar, what we called as a process. So that means there should be a process in place to implement whatever standards what you are implementing, or whatever process which is there. So that is what is a process. The third is what we call as a technical. So we'll try to focus purely on the technical part when we are going slightly deeper here, which is there. Now here in that we will be talking about the secured communication, the hardening, user authentication, security logs, access protection. So these are all basically what we say is the technical parameters for implementing the cyber security. If you take in terms of process, you have a process what is the risk assessment. So basically it means the organization should have a process in place of assessing the risk. periodically checking what is this thing, and having an incident response. The incident response is, suppose my system fails, what I'm going to do. Suppose my control center fails, what I'm going to do. Do I have a backup center? Do I have a backup? So all those things which is there, it comes in what we called as an incident response. So this is what we called as a process driven. Then what we have is the organization, which is from the user point of view. The user point of view, he should have, very, very important, is it train people. That means the people are take care on the what is cyber security. They take cyber security seriously and they train it. So that means it is equally important. The people are aware on cyber security and know what is the impact the cyber security can take. Then regularly the security configuration has to be updated by the organization. So this is also an equally important thing, which is part of the organization to implement it. The next is basically what we have is a patch management. Now, any user, if you see, which is there, what he does is he buys the asset, like he buys a computer system, he buys the software or the license from the vendor, and then he says, okay, my system is commissioned and it is okay. But the most important thing is he doesn't realize that there are patches coming by the manufacturer, there are patches coming by the OS vendor, there are patches coming by all the software vendors which are there. So if you see in most of the domain which is there, the patch management system is lacking. So this is where the organization has to put in a place what we call as a patch management. Unless you update the patches of this thing which is there, your system which is there will not be up to date. So this is purely a organization thing which is there. Then the next thing which is what we have is an audit abilities. That means periodically we should do an audit which is there. So now from the organization point of view, we are not going to touch on today's discussion because it is more purely dependent upon the organization, but it is equally important that we know that organization also plays an equally important role in implementing the cyber security in an electrical substation. And the processes, what are the processes which are there existing which is there and what should be implemented. So this is also equally. And the most important thing is the technical, which we will discuss this, which we will focus on today's discussion, that access, security communication, hardening, user authentication, security logs, access protection. So this we will focus in, which is there. So on the processes part and organization part, we will just park it aside because we are not taking in today's discussion. So how is it goes as the improvement process is, this is a cyclic. You do a risk assessment, then you do a vulnerability or mitigation, which is there. Then you have a patch management, then you have incident response, then you have an audit. And this is a cyclic process which needs to be implemented over it. So that means it doesn't mean that even you are technically perfect with all these parameters, unless you put in place a right process and you have a right organization to address all those things, you won't be in sync in achieving what is the goal to keep the substation as a cyber safe. So what is the takeaway? It is cyber security is dealing with processes and features. It is also a continuous process. Okay, now we come to the security requirements and the concepts which is there. This is what we called as the CIA, right? Now, whenever we have we exchange information in a substation between the relays to the pay computers to the operator workstation, between relays to the operator workstation to the gateway. So we have got multiple level of exchange of information between in the substation. Now, when we exchange the information, what is important? The most important thing is confidentiality. That means it should prevent from unauthorized access of information. Number one. Number two is integrity of the information. So that means whatever information I send, it should be as it is. It should not get modified or it should not get tampered. This is what we call as integrity. The third is availability and authentication. So when I send the information, if it is meant for operator workstation, he should get it. So that means it should be available. It doesn't mean that I send the information and just keep quiet. He has to be, it should be available. So these are the three important things. If you take a substation environment, that it should be confidential. Confidential means it should prevent unauthorized access. So it means if it is X is sending to Y, so Y should only get it. It is not the Z. He should not get it. Integrity means the information which is going from X to Y, it should be as it is. It should not be tampered with it. And availability means from X is sending to Y. So X, whenever Y wants it, he should get the information as it is from X. So these are the three things which is there. This is common this thing which I will just skip through, which is there, which is terminaling between IT and OT, because this is the common terminology which is being used in today's domain, where we are all running the substation through PCs, the servers, the switches, all those devices which are IT related, and we are running a substation which is OT driven, which is like your intelligent electronic devices, bay computers, which is there. So I will just rush through it if anything you want, because just for information's sake, what is, so we are running a substation basically what is it is a OT domain. Now what is the takeaway? If you take the IT, confidentiality is very important. Number two, integrity is the second priority. Availability is the third priority. But if you take an OT domain, which is a substation environment, availability is the most important priority. Let's say when I'm sending information from a operator workstation for a circuit breaker trip, it has to be available. You cannot say that I sent the information, but it got lost. Integrity. Then confidentiality. Confidentiality is because what happens in OT domain, OT you have got very less people. So that is what is, there's a confidentiality takes a least priority, whereas in operating a substation, the availability of information which is there, it takes the highest priority. But if you take the IT domain which is there, what we have, the mail servers and all this, all the IT infrastructure which is there, confidentiality which is there, it takes the topmost place. When you log into the computer, you log in with your username and password which is there. Okay, now we just come to the standards which is there. So this is a repeat of whatever I had said. I'll just brush through. So we have the NERC which is there, so which is a framework of it is a US-based standards. VDW is a German requirement of security control and telecommunication standard. IC 62443, which is the recent addition in 2014 or 15, this has been implemented, and this is purely pertaining to electrical substation environment, which is there. Then parallelly, IEEE also started the same thing, IEEE 1686. So almost the standards are overlapping, which is there. Then we have on processes ISO 62351, which is more on the oil and gas, and which is there. Then the other standards which are there, I will just go through. Okay. Now this is what is the framework of the standards which is there. We have got three pillars. One is the technical body like IC, which is defining some standards, IC 62443, ISO 62351. There's another technical body IEEE defining some standards, IEEE 1568, IC 37. Then there is standards defined by the government. For example, NERC is a US law itself. ISO 270, Liver Blanc is a law by the French government. So this is the government imposing some standards on the utilities. That means on the users. So it means the user has to comply to these standards when they are implementing any electrical substation. Vice versa, also there is, if you take the Germany VDW, in the Germany the utilities impose a standard. So that means unless you have complied to these standards, the solution provider which is there, you cannot sell your system. So if you see, it is a whole gist of a triangle, the government imposing on the utilities in turn imposing on the technical standards, and this are all coming into the solution provider. So this is a you have a technical body, you have the users, and what you have is like a mix of all this which is there, which is because cyber security is pretty important for all the stakeholders. So it is equally important we understand like in full frame, where it is, where are we in this. Now I'll just go into this what we called as a NERC SIP. So we'll just brush through the standards, what is there in the NERC SIP, which is there. Now NERC stands for basically North American Electric Reliability Corporation. So this is basically a standard on the critical infrastructure protections, on protection, which is there. And it has been started in 2007 and it is still evolving and is mandatory by the US law on the utilities who are running the substations. And there is an audit, periodic audit by the local bodies to these utilities, and utilities who don't comply, they face heavy fines and for non-compliance. So this is it's more like a law by the government on the utilities. So what these standards talk about? So if you see, this standard is more process driven. We have 11 standards, and there are 2 standards which is under discussion and they're going to launch. One is for control centers, and one is for supply chain management. Also, they are going to launch this, which is now what it says is we will just run through this. We have got various chapters into this standards, NERC SIP, so which is primarily North American, so it is predominantly applicable in US and Canada, which is there. So this is what it says, that BES protection systems. So I'll just brush through. Now what is, I'll just quickly run through is what is there. The SIP 2002 states that cybersecurity category. So it says that all assets what you are having in a substation, you need to categorize it. And when you categorize it, you need to define it, whether it is a low risk, medium risk, or high risk. So that means there should be a proper document which mandates that all the this thing has to be categorized, whether the assets can be the overhead lines, the transformers, the reactors, the circuit breakers, the isolators, the disconnectors, the PCs, the control stations, whatever assets which are there, they need to classify in that this thing. So this is what we called as a SIP 002, which is one of the part of the NERC. It talks about this. The second chapter which is there, it says that should be security management controls. So which says that there should be a cyber security policy and indicates the way we have ISO 9000. So it says that who is responsible for what and what is it which is there. So it basically talks about your delegation which is there, and who is, that means it is talking about some organization to be in place, and if there is a cyber security, whom they have to report, what is it. So it talks about more on the management controls which is prevailing. So that means, in other words, when I'm running a substation, I should have this in place. When the auditor comes, I should be able to show this as a proof that yes, I'm complying to SIP 003. SIP 004 talks about basically the personnel and training. So it says that you need to prove the way we have for ISO 9000. So here also you need to prove to the auditor when it comes for an audit, saying that yes, I have 20 people into my team in the substation. The 20 people have been trained on cybersecurity, on how to do this, how to do this, and how to what is it. So they have undergone some training, and you need to demonstrate it when it comes to the audit. So it talks about you should have a personal and training implemented in your organization or in your substation. The next, it talks about the electronic security perimeter. So basically what we have with the substation, you have got substation fence. So it talks about what all perimeter you have. Like it can be electronic perimeter or it can be physical perimeter. So I have let's say a physical perimeter, and then I have an access control. So where there is a fingerprint, which is when I scan my fingers, then it allows to access. So that is also one level of access. It talks about that when you're logging into a computer, it asks for a username or some password. That is also a second level of security. So you have to define basically what all the electronic security perimeter you have defined in a substation, whether it be in a fence or you have some camera controls or whatever is it. So you need to define this in this, and these are all basically audited by the government agencies in North America. Then it also talks about the physical security. So this was there's a difference. This is electronic security and this is a physical security. Physical security is basically what you have, what we saw, the fence with a proper with a door, with a lock and key and arrangement which is there, and each key has an access to each of this, which is there. So this talks about the physical access or the physical security what we have in a place, electrical substation. Then the next is, which is slightly, now it was generic, which was more on the process from the user point of view. Now here from SIP 007, it talks about the technical thing. Basically, it talks about the ports and services, service patch management, antivirus, malicious code prevention, account management, monitoring. Now, in other words, what is the security management you have in place? That means, are you in your switches, are you disabling some ports which is open? Do you have a patch management in place? That means when you get the patches from the manufacturers, let's say you get a patch from the Microsoft, or you get a patch, you have a, let's say, Schneider system. So if you are getting are you getting regularly patch from those guys, and how are you implementing those patches which is there? So that you also need to show them a proof that yes, I have a patch management in place which is there. Then I also have malicious code prevention also in place, which we have antivirus and what we call as a whitelisting. Whitelisting is I don't know how many people are aware about this. Antivirus we are very commonly known, but whitelisting is I'll just stress over here because this is a very important feature in on the computers what we use in a electrical substation. Whitelisting is basically is a software which is there, which allows only specific software to be installed in the machine. It will prevent from any other software being installed or any other software which is being there. Now, for example, if I buy a computer for my substation and I have installed the whitelisting which is there, and tomorrow if I come and say I have an Acrobat PDF writer in this thing and a license and I want to install the PDF writer, sorry, it's not going to allow you. So that means when you buy the computer, when you buy this thing from the manufacturer, it will allow you define that yes, I need Microsoft Office, I need this, I need Acrobat Reader, okay, I need this thing, okay, paintbrush is not allowed. So you list all the softwares what is being you will allow which is to be used. And once it is there and is installed which is there, then it is tamper proof. So even if you allow through your USB keys or through a CD drive, the computer, it will not allow you to install that. So that is what we call as a whitelisting. So this is a whitelisting is a very important one of the parameter which is there. We will talk when we go in detail. Then it talks also about this account management. Account management is basically what we have the users. Now, for example, something has got chief maintenance engineer, chief engineer, and then you have a deputy engineer or something which is there. So about 4 levels. Now it also talks about that which computers are allowed to what level which is there, what is it. Do you have an account management in place? So that means a user X who is a deputy engineer is only allowed to access only certain amount of information. So this is what we called as an account management. Now then the monitoring, how are you monitoring the system? So that means you are sending the traffic, whatever the data traffic to your load dispatch center. How is it? So this SIP 007, which is part of the NERC, which mostly talks about the technical part of the implementation of cybersecurity in electrical substation. Next is what we have is SIP 008. It calls about is incident response planning. Now, this is also a very important step. Now, it talks about basically if there is a cyber attack, what are you going to do to restore it? How long you will take? Do you have backup? What is it? So all those things are basically defined, which is there. So the organization can define, yes, I have a backup system in place, I have a backup control room. So I have one control room and I have backup control room. If this thing fails, then automatically switch over into another this thing control center. So these are all the things which is there, and my downtime will be such and such. So this is what we called as incident reporting. So that means whenever there is cyber attack, what you do, where you report, this is one. And when there is this thing, how do you respond to it, which is around, what are your processes in place, which is there. So this is also part of a, this is like a technical as well as organization, which is there. So something on incident response and planning, which is there. So NERC also talks about this, which is there. Then the next is, which is there as a recovery plan. Now, if you are, let's say, haven't been attacked by a cyber attack, what are your recovery plans? That means whether you have the backup, you will move to another control room, you will change the router, you will change the switch, you will purchase some new switch, you will check this whether the computers are totally gone, then you will buy a new computer. What are your recovery plans, which is there? So this talks about the disaster recovery, which is part also of the standards. Then the next, which is also talks about your configuration change management and vulnerability assessment. That means how it talks about your assessment of your vulnerability. So it means it is like, are you having some periodic audits? Are you checking your system in place? What is it which is there? So this is called as what we have is a vulnerability assessment. Then the last, which is there, it talks about the information, how you are protecting the information. So whatever information on the cyber security, how are you classifying as which is protected, which is not protected, who has the access of the information, what is there. So this is about this NERC, which is there, which is talking about. And if you see the whole NERC standards, which is there, what we talked, what we discussed in just the past 10 minutes, is mostly, if you see, it is all driven towards the organization, which is there. And as I said, it is by US, by North American, by US and Canada, it is a law where the users, like the substation people, like the electricity utilities, they are bound to implement this, and they are audited by the government agencies. And if they don't comply, they are penalized. So US and Canada are the first one which is there, and we don't have any place in the world where where there is such a strong push by the government on the users to have this implemented. Then we come to the technical standards, which is IC 62351, which is there. So which is which started that this IC standard started and setting up in 2010, and this was purely focused on meeting the substation environment, the cyber security. So I will just browse through. I will not go into much deep over here. So this is, as you know, the in a substation environment we have IC 6180, which is a communication standard in standard protocol in substation environment, and is widely implemented all over the stations, which is what we see. So how does it map against each of these standards, which is managed? And we have got 10 chapters, which is there, which is chapter 1 to chapter 10, which is there, which has been, as I said, which has gone as a standard in 2010. And it talks about the profiles and TCP, IP. It talks about the profile in MMS. It talks about the security, which is there. And the most important thing, it is talking about the security instrument. Like it goes one level above what we call as encryption, because in encryption of data in the substation, which is still is in a very nascent stage, because no one has really gone into really implementing in that level of cybersecurity. Okay, now what I'll do is I will touch on the 5 steps from what is existing today to a secured substation. So now what we talked is all theory. We talked about what are definitions. We talked about what is cybersecurity. We talked about what is it which is there. We talked about the standards, we talked about the NERC, we talked about IEC 62351. This, if you see, all these are all, it's all theory, because I know the theories are important. But now, when you come to electrical substation which is there, we will check, we'll discuss now. What are the 5 key steps? I'm not saying these are the keys, there are no other steps, but these are the key and essential steps which is there. Because of the paucity of time, I'm just focusing only on 5. There are other things also which we can discuss it out, which is there. So first thing is, we just discussed the electrical, what is substation which I see, which is there. So if you see here, we have Ethernet LAN, which is a red color ring. We have some bay computers, we have some relays which is connected to the LAN, the switches, and we have the SUI. SUI is a system user interface, or what we call as a operator workstation. Then we have a telecom network, which is there, and then I am sending this information to a local, what we call a load dispatch center, where there is EMS, what we call energy management system, or distribution management system, or a SCADA system. So this box in the pink is what we call is within the substation fence, which is there. So this is what is a typical architecture, or a typical, the layout of a current electrical substation. What we have intelligent relays, intelligent bay computers, all connected in LAN, talking to the workstation, and then we have a gateway device which is sending this information over the telecom network to the basically the load dispatch center or the SCADA center. And then parallelly, we also have one more is a corporate authentication server, where you will do some authentication, which is there. So this is the broad, the network which is prevailing in the current environment, which is the current practice, which is there. Now, what is the first thing? What we do is step 1, or what we say is the basic step what we should do. The first is what we do is the access protection. Remember this slide message, what we talked. Now we will talk on this, each of this is the access protection. So how you implement an access protection in that environment which is there. What is now, first is you have to implement an access protection. Now what you do is you have this electronic perimeter. So it is, you install a process and procedure to know who is entering into the substation. So basically you have a log just to check that yes, person X has come, person Y has come, visitor A has come, visitor B has come, which is there. And this is one way of implementing to know who has entered into the electronic security perimeter, whether he has used the access or he has not used the access. So basically, what we do is we maintain a log, and which is also part of the NERC requirement which is there. Then the second is basically putting a firewall which is there, and into the network. The firewall is one which is connecting between the substation to the telecom network, because this telecom network is, you have other devices also being used, these telecom networks also which is there. And you also have a firewall in place which is installed in the SCADA control center which is there. Now what does the firewall do? The firewall is nothing but is a layer 3 switch which only allows the traffic which is there it is meant for. Now, for example, the information which is meant to be sent will be sent to this firewall. It will not allow any other information from this substation to go out of this telecom network. And the same thing happens over here. When I'm sending, let's say, a tripping command which is there, which the firewall will recognize that yes, it is a tripping command and it will allow to pass. And the same thing when it is sensed here, the same thing will be sensed down, and it will be going to the particular device. So this is what is firewall is basically a combination of hardware come software, which is what we call as a layer 3 switch, which is installed in the gateway which is there, as well as over receiving stations here. So which is allowing only that particular level of information to pass through. It will not go. Now, for example, in this network, I may have, let's say, some voice communication or some data transmission, some other information which is there. which is not relevant for this as well as for this. So the firewall, what is there? It is going to block all those things which is only pertaining to the SCADA environment or the control center and the substation. It will allow you to pass. Now that is what we say. It is a process. A is a process entering who knows who is entering into the substation. B is a firewall. Now what is the benefit the user gets? The first is restrict the security perimeter of trusted personnel. So when you have a logbook, you very clearly know who all are coming, who all are going out, and who all are accessing. So it gives an indication that there is a problem. What is the problem? Now, if you have, let's say, a lot of visitors coming in, so it gives a feeling to the management that yes, my system which is there has got a high potential which is there. Because more than I have got 5 employees, but in a day, if I see 30 visitors are coming in, the traffic, the firewall, what it does is it blocks the incoming traffic and identifies traffic which is there, restrict the incoming traffic, block the unwanted traffic. So that means all the unwanted traffic which is supposed to go on this network which is there, it will be blocking that and be allowing only those information which is relevant to come inside the station or come into this control center. So this is the first level of access protection what we define, which is there. The step 2 is what we call as a hardening. Now, when we talk about hardening, which is there, we discussed what is the hardening. Hardening is, most of the devices, if you see, are all coming with Ethernet LANs, Ethernet ports. Now, for example, if you take a relay, the relay is supposed to operate or trip a circuit breaker or when it exceeds a threshold. So, for example, if I am having a distance relay, if let's say if the distance exceeds zone 1, which is the fault is in zone 1, then the zone 1 element should operate and the zone 1 element should operate and the relay should trip the circuit breaker. So this is what I expect from the substation as an engineer, and I expect the relay to be delivering that output. Now, if I am connecting the relay into a LAN and let's say the port is not hardened, so which means that if I give some junk data, the relay instead of behaving in behaving in a proper in a one way, it will start behaving in a different way. So this is what we called as a robustness or hardening, what we call, and then we are disenabling some ports. For example, I'm using a 20 port switches, but in a substation I'm using only 16 port and the rest 4 are vacant. So what I do, I disenable all the ports. So that means even if you manually try to put in or plug in your computer or put in some this thing, it will disallow, it will not allow you to access the network. So this is what we call as a hardening. Hardening is also basically what we call as a whitelisting, what we discussed earlier. So I do a whitelisting on installed all the PC computers, which is in A. I installed in my operator workstation whitelisting. I install the whitelisting on this computer, which means that it is only allowing the specific softwares to be run on the computer. It will not allow any other softwares to be used. Then hardening. Hardening is basically what is there is robustness, or what we say is robustness means the relay, what I said an example which earlier, the relay which is supposed to perform a protection operation, it will perform protection operation. And even the data is coming in the Ethernet port, it is not going to alter its operation. This is what we expect the relay to behave. So that is what we say. So there are some tests also, and there are some standards which says that, and there are certificates also available which says that my relay is hardened. When I say my relay is hardened, means the relay will undergo some series of tests which is there, and what they do is they put in a lot of traffic into the network which is there, and they will try to see even if whatever traffic we put in into the relay is behaving in its own natural way. What we say is a tripping and all those things which is there. Then we stay the hardening of the network, which is the PRP or HSR protocol, which is there, disenabling the ports of the switches, which is there. what is the benefit which is there? So the stucknet protection, which is one of the the virus which is there, it protects. You have the protection there. USB key protection. That means even if the USB key is there, it will disallow your user to plug in the USB key, because if I install in the operator workstation, I disenable the USB key. That means, in other words, even if I put a USB key, it will not allow to read the information from the this thing. It is a malware protection. And in this, what happens is you are operating on a totally what I say is a cut-off sort of environment. So basically, what happens in this, even if you get an update or you don't get an update, it doesn't make so much of impact. Which is what I would say. Benefit is what we say is no updates required. Weakness, none. Virus versus antivirus, which is there. So this is the second level of what we called as the protection. What we give. So first level, what we called is access control, where we give firewalls. Second level, what we called is hardening, which is there. Now we come to the step 3. Step 3 is what we called as a user authentication, which is very important. So we talked about access control in the technical. We talked about what is hardening, and then now we talk about the user authentication. User authentication is something like your very simple thing as like a password. Now what happens is this user who is supposed to access this relay, he goes into the laptop, he plugs the laptop into the relay, and he starts communicating. So this is what we called as like a human to machine interaction. So this is the human wants to talk to the relay, he uses the computers, and then he accesses it. Now, if you see the human being who's talking to the relay, there are multiple informations or multiple levels which is there. The first thing is he can download a new firmware into the relay. This is one type of information. He can change the settings, protection settings. That is another level of interaction. He can change the IC 650 settings. That is another level of information. He can download or the disturbance records, the event logs, which is that is another level of interaction. So basically, a human being, when he's interacting with relay, you will have multiple needs, multiple requirements. One may go for upgrading a firmware. One may go for changing the protection settings. One may go for accessing the event logs and DR files. One may go for only accessing the 650 settings, which is there. And one may also go for only accessing the logics. He wants to change the logic of this thing, which is the relays. So this is what is the level of which is there. So what does this thing define? So basically, if you see the whole process, you have got multiple level of accesses and all talking to one relay. Now, this is the part of what we called as a 62351-8, so which is role-based access control. So RBAC is one defined in 62351, which says every user has got a role to play. Okay, it is not only it is discriminating between the, and every user has a role to play, and the role can be either he can have a read, he can have a write access, or he can do a read-write access. Now, what he can do, he can write only, he can write on the settings, he can do on the firmware, he can do on the configuration. Which is, configuration can be protection setting configuration, or it can be on a 650 configuration, which is there. So basically, if you see, the standards define that every user should have a role, and every role which is there should have an access rights which is there. So it is not like a universal thing which is being given currently. So this is what it says. So you have basically user authentication. So you have what we say is we have a security server. So in the substance, which is now we are coming to an additional device. So we have the user login. So that means all the devices in the substation are with RBAC complying to this the previous standards, what is 62351-8. So that means in a substation, I am procuring all the devices, that is my operator workstation, my bay computers, my relays, all complying to role-based access control, and it is complying to 62351-8. Now here what I do is I have a security server, and for each of this device, what I do is I define my role, I define the users, and I define the rights. So there are three things to be defined. One is the role, users, and the rights. And that gets defined in the security server, and this security server will push this security configuration into all these devices. So this is defined in 62351-8. So this is only the weakness here. What is there is this is only if someone says I need complying to 62351-8, then we have this solution. But someone will say no, I don't trust IC, I will go with IEEE. Then that's a different story. So this is user authentication, which is there. It works on this philosophy. Now, what is we normally have the common understanding is the password. Now, if you see the passwords which is available in the devices today is there are multi-level passwords. If you have level 1, let's say you can do 1 activity. If you have level 2, you can do 2 activities, and if you have level 3, which is there, you can do 4 activities. So this is what we call as the traditional password, which is there. So that means every password has got a user level. So if I put 4 times A, so I go to level 1, 4 times B, I go to level 2, and 4 times C, I go to level C. Now, for example, you want to change the protection setting. That means you have to go to level, if I define that if I go to protection setting, that means I have to go for level 3 password. So he has to enter CCC times, and then he comes over here. This is what we called as a traditional password philosophy of implementing, the access control. Whereas if you come to the 62351, which is there, which is the role-based access control, here what it says that you have a user, he has a role, and he has a rights. This is what that means. This user only can access do this. He cannot do this. So that means as a Bhaskar, which I am a user, I can only access the settings, protection settings. I cannot access the security configuration. I cannot access the firmware. So this is defined. So that means, in other words, even if I try to do it with my password, the relay or device will not allow, which is there. Now, this is what we call as the RBAC, which is slowly getting implemented in most of the places what we have seen, which is there. Now, if you see, this is an example what happens. So when you just touch the bay computer, what happens is you will see the list of the users who are already populated in this device. So that means this device can access, allow access to this following 6 people: Rob, Walter, Gustavo, Jesse, Mike, Andre. So it means it is going to allow only users. So what I do is, if I am Rob, I go to the Rob and I put my password. So when I put my password, whatever the has been defined, only that I can allow, I will allow to do. Now, for example, as a Rob, if I am allowed to only change the protection settings, I can only do the protection settings. And Walter, who is a hardware engineer, he is only allowed to access only the firmware settings. So he'll only do the firmware settings. So this is what we call as a RBAC. Okay, now next thing which is there is what we have is the security logs. Now the way what we have is the event log. We should also have a security logs just to check and prevent whether there is any type of operations which is unintentional operations which has been carried out, or unintentional operation has been done in the substation which is there. Now, how do we do it which is there? Now, by virtue of today's this thing which is there, now if you take this case, and as a Rob, if I enter wrong password, I know I'm Rob, but I enter the password wrongly. So what happened is the relay will log in saying that Rob entered the password at wrong password at this time. So I entered it twice. So that means I'm forgetting it. So there can be two cases, whether I'm a genuine Rob or ungenuine guy. So this is what is the security logs which is there, which is also important, which is there because all the devices are now capable of having the security logs generated from these devices when you have this RBAC installed. So this, what it does is it flows all the logs which is there into the security server. The security server is doing two things which is there as per 62351. One is it is imposing your users, it is imposing the rights, and it is user which is there where he is allowed to do particular access. So he is implementing the RBAC, and simultaneously also it is reading the logs of all the devices into its server. So that means this security server is something like a like a gatekeeper or like a, so it is to be checked by only by some higher level of some high management guy who has access who can check it. Now this is like a log what will come out. Now this is login, password, authentication successful. So that means who is the user, this is there. And if you click on these details, it will show that yes, he is logged in. Authentication attempt failure, disconnection successful, authorized request to bootcamp, login, password successful, disconnection successful, this thing login successful. Now when it reads authentication attempt failure, which means that there is, you come to know that someone has wrongly tried to enter this thing which is there. Now if you can, when you click on these details, it will give you who is the user. It is Rob. So then you ask Rob, hey Rob, what has happened? Why did you try to log in? So there can be two answers. He says, I mistook it, or he says, no, I have not done it. So if it is not done it, then someone else has done it. So then this is what we call as a security logs, which is there. It is collecting from all the devices and populating in the security server. Now this is what is the detailed information you will get. Connection failure, Gustavo, warning, which is there, operation service. Okay. Now we talked about the access control, we talked about the hardening, we talked about the user authentication, we talked about the security logs, and now we're talking about the last important thing which is called is the secured communication. Secured communication has in fact not gone in a much big way which is there, but it is still in a, what I say is a theoretical state. The secured communication is nothing but encryption. What today's mobile, what you have, whatever information you send on WhatsApp or this thing gets encrypted and reaches this user. So the same philosophy is what is people are trying to percolate down to electrical substation. So, but because of the mismatch and all those things which is there, this has not picked up, or no one has really implemented in full spirit on this secured communication which is there. So this is what is there. So it is something to do with the encryption which is there, between encryption of the information which is flowing within the stations and which is outside the substation. Outside the substation, yes, I can agree we can have an encryption, but within the substation, encryption is still, it is in a very, very preliminary stage. People have not gone to that stage because there are still some discussion or debates on how to implement it and how to, what is it which is there. So this encryption is still which is there. So now if you take up to step 4, which we see that a lot of users have implemented it, which is there. Now if I just to summarize this, the step 1, what we say is the access level control. So when you try to implement this process which is there, you are almost securing or substation almost 30% safe. Then you are doing some hardening, whitelisting, then you're increasing your system to be more reliable, so which is maybe 50 to 60%. Again, you are going one step further, you are using what we call as authentications. What I say is a role-based access control, so you are doing step 3, that means you are increasing the reliability to further one step, which is there. So there you increase you are making your system almost 70% reliable. Then you are implementing what we called as logs, which is there. So you are analyzing the logs and you are taking some corrective actions based on the logs. So there you slightly go up, which is there is 90%, which is there. And the last, which is there, is the secured communication, is what we say is this your internal communication, which is there, and your process in place, which is there. So this is closing to 10%, another 10%, which is the system in place. Your what I say is secured communication, which is there. So if you take the whole 5 steps, which is there, step 1 and step 2, if you do it, which is there, you are almost preventing 55 to 60%. So these are all statistics given by the users. And when you go implement 62351, the standard in the right spirit, you increase the reliability further. And when you implement your is your organization process, the training, the patch management, all those things which is there, what we saw in the previous discussions, people implementing this in this thing. So we are increasing your reliability to further levels, which is there, and you can further enhance it by going in for secure communication. What we say is the encryption, which is there. So encryption, we don't talk because in globally, no one has really implemented in right spirit within the electrical circuit. But okay, outside the substations, we have encryption also in being placed, but within the substation, we have not seen a single case or a place where the encryption is really implemented. So my message, which is there, is the cyber security, which is like it's a continuous process. You have a risk assessment, you have a vulnerability mitigation, you have a patch management, response plan, an audit. You can either have it from a third party, because there are third party auditors also who are available today in the market, who can audit the whole systems which is there and tell you that yes, what is the risk, what is the vulnerable which is there, and what is the basically whether your systems are up to date or what is it which is there, and whether do you have. So they can assist you in making the system more cyber secure, which is there. Now, if we just to conclude, what is there is so a lot of people have a message that no, cyber security is only technical. We are just, let us be blunt enough that it is not only the product which is there, it is more to do with the processes, more to do with the organization which is there, which is implementing, which is there. And that is the reason why I was driving you to the NERC standards, just to tell you how it is there. And the technical, yes, I agree, it is one part of the domain, but the other part which is also equally responsible is your putting an organization, putting a process in place which is there. So this is all as a brief summary, as a brief this thing on today's this thing. Now coming back to the Indian context, so this is all about a general which is there on a technical this thing which I have talked. Now coming to in India, where are we and what is it which is there? So now let us go into this step 1 and 2 and which is there. Let us go over here. If you see, the access control is being practiced by most of the utility. So they have perimeter, they have this, what is it, they have a firewall in place. Most of the substation have a firewall. So the access control which is there is really practiced pretty strongly in India, what we have seen so far, because the user also have got this thing. So now whatever we are seeing, people asking with firewalls, people are asking with you know, with user passwords and all those things which is there. Hardening, when I take which is there, it's slowly popping up because there are certain certification agencies also has come up which is there. So hardening is slowly coming up which is there. So it is the stage is almost, I think it's 20-30%. User authentication, as I say, it is since it is released in 2015, which is there. So it is still in a nascent stage. Mostly we see in Europe and US implementing this user authentication. So we don't have any case in India where you really see this sort of an access control, a role-based access control at the device level. I'm not talking about the operator workstation, but at the device level. We have not seen any cases which is there, but slowly things are maturing because the devices are now slowly coming up. So we can see. So this is close to 10% what we see in Indian market and the Indian utility which is there. Security logs, we have still not gone any further on security logs as far as we don't have any users who are really tapping the security logs from the devices, putting in a security server and analyzing the security logs and really taking the decisions or whatever on security logs. Secured communication is still far away, which is there. So secured communication, even the world also has not progressed into that domain. So I'll just keep it which is there. So now to summarize here, if I take if you ask me what is the protection level, which is if I take this slide, so we are step 1 and 2 mostly we are doing in India, which is what I see. Step 3 and 4 is still we are in the nascent state. Step 5 is almost nil, because in fact if you take very few, I have not come across any utility where they have put an organization process in place in terms of in a substation I'm talking about, where they're talking about some patch management, incident response, giving a training which is there. So all those things are slowly picking up, which is there. But in the control center side, where the load dispatch center side, it is slightly in advanced stage, where they are really putting in that in place. But as in here, we still have not moved into that domain. So I will, with this, I close my presentation, which is there. So basically, what I've planned is just give a brief overview on what is prevailing in today's cyber security, specifically for electrical substation, which without going into very much technicality, because if we open the standards and this thing, it will open a very big chapter and this thing. And the most important thing, what I wanted to just emphasize is focus on this 5 technical things which is there: access control, user authentication, hardening, security logs, secure communication. These are 5 technical things which is really important or key for having the substation to be cyber secure. Whereas the other domains also there, like organization, the process, the risk assessment, the patch management, auditing, training, security configuration, which are also important. But do keep in mind that these are also a key this thing to play a role in having the whole substation to be cyber secure. So any questions are there, we can take it up.
Any questions? Participants can raise your hand. We will unmute you.
Was it too technical that, or it was, I don't know, or I made it too general? I'm not able to.
Any queries from participants?
Raghav sir, you can ask the question.
Hello, sir. Overall, it was a very nice presentation, sir. I have one question.
Yeah.
In generally speaking, the SaaS method, which is software as a service, has taken over the world. Like, as you said, Microsoft Office, they keep giving the updates, and I'm talking just as a client or a customer here. We get entrapped in this process where they keep sending us updates, and we have to keep purchasing that. So when a manufacturer like yours, like Schneider Electric or GE or someone else, supplies a product, do you also do the same thing? Because in future, I see clients will get entrapped into the cycle where they always have to get the updates. They have to pay for the service. So how do you see this happening in the future?
Two things which is there now. First thing which is there, when you have the patches getting released by Microsoft. So now, for example, I have my HMI software which is running on Microsoft, and it is let's say version 5.1. And let's say I released this 3 years back, and then today I get a Microsoft patch, and when I put the patch and I run the software which is there, and I see it is, let's say that hypothetical example, it is crashing. So that means my software which is there was vulnerable. The moment Microsoft corrected and gave a patch, so that means my software which was there was vulnerable and it was not able to tackle. So what I do is basically I release a patch for that. So when I know that this is which is there, I release in my website that yes, declaring that this is my issue, that with the Microsoft patch number such and such, with a OS version with this thing which is there. If you have installed, let's say, version 5.1.1, and you might have an issue like this, so it is recommended that you upgrade it to this with a new patch. This is now the problem is coming is this is there on the public domain, and now very few users really go into that domain and really check and gather this information and do it. So what they do is there are certain users like what we have seen in Europe. They offload it to the some third-party vendors which is there, and they give a annual contract to them. So these guys are basically will tap all the software. Let's say in one substation you have, let's say, 10 softwares. So they will periodically go to their 10 websites which is there, cater all those things which is there, and then pass on the information that yes, this is the information. So now, for example, Microsoft patch has been released today. It may so happen that it will not impact me. So I need not release my patch. So if there is a vulnerable which is there, then I release the patch. So now this is a continuous process. So what we have seen, because in India we don't have that in place, but in Europe we have seen users EDF like in French utility, they have offloaded to one service provider. So these guys, they will take all these things, they will interact with like people like me, with G, with ABB, with Schweitzer, with Siemens. They will collect all the patches which is there of the relevant firmware versions. They take it, they diagnose it which is there, and then whatever is applicable, like what we say is the patch management which is there, they will implement it which is there. Now this is, if it is there, it is not that releasing the patch is, we are charging it. The way Microsoft gives free of cost, even we also giving free of cost. The only thing is there should be some system in place to collect it, to know yes it is applicable, and then apply to it which is there. So in India we still have not really gone into the patch management in a real professional way.
Yes, sir. Thank you so much. We have another question for you posted by some participant. Sir, if we need to learn about cyber security in power system, where can we learn it, sir?
Where you can see now, now the question is the cyber security which has gone is now it is more further. Now we have got certification programs, like what you have. This thing is these auditors who are there. Now this is it has gone into a big domain where it is there, and you get certified. So that means you go through a certification agency, and mostly they are in US, and some 2-3 agencies are in Europe. But there, what you do, you get certified as a auditor or the cyber security, which is there. So just like what we have for project management, PMP, or some this thing which is there, you undergo a professional course which is there. You sit for an exam, and then you get. So this is one level of going into really into a basically a cyber security domain where you really go into this thing which is there. So that is one direction, and other direction which is there is you come into this thing in the mainstream, like getting into the organization, and then you get attached to the cyber security team which is there, and then you learn in that by virtue of that process you learn. So this is two paths which is what we have seen people going in, because all the people who are there in the cyber security team, what we have in we have just two guys in India who are sitting in Gurgaon, and then we have a team in Dubai, and our head office which is there for subscription is controlled in US. So basically, it is a mandate that they have to go through a certification program, and then they are all getting certified, which is there. So there is that is the process, but it was not there 5-6 years back when people were going into cybersecurity domain and learning, which is there. But now it has become like a certification program itself.
Thank you so much, sir. As a faculty of engineering college, I have a question personally, sir. The question is, how can I train my students, and how can I include that syllabus in my curriculum, so that my students will be industry ready when they come out of the college at 4th year?
Okay, now this is a good question. Now the fact is, if we really go into the standards, what we'll do, it will become very theoretical. So which is what I would say, I wouldn't say recommend, but there are certain, I think, I don't know whether some books are available or not, but there are certain literatures which are available, which is there. We can concise and we can make topics like what we have, talking about what is a firewall, talking about what is this in detail, this role-based access control, what is it, how it works, which is what is encryption, and what is this thing. But in that case, what happens is we need to interlink with your the communication systems, what we have in this subscription, that is 61850. So it can be developed. It is not that we cannot develop. It can be developed. We can do it. But frankly speaking, I have not seen any syllabus or someone in the college putting a cybersecurity which is there as a thing. But it can be developed. I'm not saying it, and it is. I think it is good to develop also. Where people should be aware what is cybersecurity and what is the importance of having a system to be cyber secure.
Yes, sir. As we are autonomous, we have that rights to change our curriculum with the approval from BOI's members, sir. So, can you explain in short, like, what is the scope there in the industry for the next 5 years if my students are studying and we are including that in the syllabus?
Now,
and
okay, I got your point. The scope is slowly popping up now. I would say 5 years back it was not like that, because I work in Middle East, so I know in Middle East it is very stringent. Because when I walked into Middle East, we had a case of Aramco's computers getting hacked, and the whole thing went on a haywire. Their oil production was shut down, and after that, it was in 2012 or 13, which is there, I don't remember. After that, the whole Middle East turned into this thing, and they made it into cyber secure, which is there. Now, if you see here, slowly the opportunities are popping up, which is there, like in terms of designing the system for a cyber secure for this thing which is there. And what we see mostly is the cyber security. The percolation has gone more to the control center side. We have seen whatever this joint control center, whatever you see. We have a case we have seen very recently Adani, where they have asked for a main control center and a backup control center, because Adani is a transmission utility, which is a private utility. We have seen in Himachal Pradesh also, they have taken a World Bank loan and they're setting up a control center. And the cyber security, what they have asked is at a pretty high level. So slowly, control center domain, we are seeing a lot of activities which is there. And I tell you, there is a dearth of professionals who are not to understand the real what is which is there, and take it which is now. For example, I'll tell you a very recent case. We were bidding for a project in Himachal, and there it required auditor, independent audit has to be conducted also periodically for 3 years. And believe me, we approached all the IT firms, and none could understand what do we mean by audit in a electrical substation, because we were taking their computers, we were taking their Ethernet switches, we were taking this thing, but then they could not understand. So frankly speaking, as on date, we don't have a single auditor who's independent, who's doing it. So you can just imagine the scope of activity which is to come in next 3 or 4 years down the line, which is there. And when you have this, the certification, all those things, you will pretty sure to see a boom in this domain.
Thank you, sir. Thank you, sir. I have another question from the participant. In one of the slides, there was cyber security is useless inside the substation. Can you explain the reason in brief?
It was part of the secured communication. You are talking about this?
I don't get, because one of the participants has asked. I think yes, sir.
Okay. Okay. I'll just tell you. Now, within the substation, we have 2 levels of data communication. Rather, I would say 3 levels. The first is the data communication between the devices and the operator workstation. So I'll go to the first slide, which is there. So this will be a major when we talked about this one. So we have the first level of communication is between the devices, which what we say the relays, and the operator workstation. So this is what we call as the information of flow of information from here to here. The second level of information is what we call is a peer-to-peer. That means it will go from a relay to relay. It will not even come to operator workstation. So that what we call as a peer-to-peer information. That is the second level of data exchange happens. The third level of data exchange, what it happens, which is to the external world. So there we have from the devices, it can go over here, or from the operator workstation, it can go over here. So we have 3 levels of data exchange, which is happening in the station. In this, the first level, what we talked about between the relay to this thing, it is more like your controls information or your mimic or whatever is it, which is there, which is more flowing on 650 protocols, which is between the relays or the BCUs to the operator workstation. This is one. And the next most important thing is what we call as a GOOS, general object oriented structure, which is there, is called, which is what we call as a peer-to-peer communication. That means the relay communicate between them laterally. It does not go to the upper level, what we call as a operator workstation. It just communicates laterally, and then it exchanges the information and it does the processing. Now, for example, a typical station which is there, let's say the main one has operated, and let's say you want to give remote tripping to some other bay. So in that way, what happens is this information from this relay will flow into this information, and this relay, on receipt of this information, this will do the necessary operation. So this is what we call as a peer-to-peer operation. Peer-to-peer. So in a substation, we have all the three level of data exchanges which is there happening, but we don't have, what we say is all this information are not in a encrypted format. So we don't have a secured information which is there. So which in other words, I mean, what I mean to say is this information which is flowing from here to here, if I tap it, I can easily decode the information. It is not encrypted. So this is what is, the world has not gone into that stage. The world is still in without an encryption. So that means within the stations, we don't have any encryption which is there. So I hope, I don't know whether it answered the query on the data exchange within the substation where.
Yes, sir. Yes, sir. It is a nice answer. We got the answer for what we expected. Thank you so much, sir. And the queries are over. If you, participants, if you have any other queries, you can contact the resource person in person. Now, Mr. Akshay can take over this. Akshay or Hari?
Sir, thank you, sir, for giving us your lecture today. We received lots of technical information today.
Okay, it was good.
Yeah, yeah. Thank you so much for accepting our invitation, sir. Thank you.
Thanks a lot.
Yeah,
Thanks
thank
a lot.
you. Yeah.
We have an announcement for the participants.
And
Yes, madam, please.
participants, tomorrow we are leaving a break, and in day after tomorrow we will be having again 2 sessions. One session is by Divya. She is a postdoctorate fellow in Singapore University, and the second session will be handled by Mr. Selva Kumar of ABB. Right. So let us meet on Thursday. And Bhaskar sir, again we are very much thankful to you. Thank you, sir.
Thanks a lot.
Yeah. Thank you, sir.
Thank you.
Joel sir, any other information?
Nothing, ma'am.
Okay.
Oh, thank you, ma'am.
Yeah.
Participants can fill the feedback and it will be open till 1 p.m. Complete the feedback before 1 p.m. and you can leave the meeting now. Officially, it is over. Thank you. Link is already shared. We shared the link 6 times and I'll also share the link one more time. 1 minute.